Okay, so 1.3, today we are still solving multi-step equations, so the objective is pretty much the same. The difference is that these multi-step equations have variables on both sides. So we have done one-step equations in 7th grade. We've done two-step equations in 7th grade. This week we've been working on equations where you have to use distributive property or combine like terms before you can solve. And today I'm going to put variables on both sides of the equation. So the steps to solving an equation, was it Kevin that said, actually look exactly the same, except I added one thing. In between the old step 2 and 3, I added a new step 3. Use inverse operations. Oops. So I'm going to put a star there. Use inverse operations to isolate the variable. Isolate means get the variable by itself. Okay, on one side of the equation. So we're going to move all the variables to one side and all the numbers to the other. And then we will use inverse operations to solve for the variable. We have to remember that whatever we do to one side, you have to do to the other. So I put that on there again. And then there's your first example. So you can write it down. I'll wait till you guys are all done writing before we get started on it. Oh, I am so sorry.
That's okay.
You guys like the color green? Green? Okay. Okay, we'll use green first, and then we'll do blue. Yeah, it's okay. So what we did was we subtracted 2x from both sides to get positive 3x on the left. Then we subtracted 2. Divided by 3, and we got x equals 4. You should always check your answer, especially on a test or quiz. Got it?
Got it.
Okay. So we do have a word problem. I do want you to write it in your notes because it's always good to have an example of a word problem in our notes. On the homework, so yesterday Rose came and found me and asked me, on the homework, do you expect us to write the word problem every time? No. So on the homework, you can just write down the important information. In your notes, it's always a good idea to write the word problem because when you go back to your notes to help you on your homework, you need to be able to see how we translated the word problem, right? If we ever have notes that require like 5 word problems, I will print them for you, okay? But this is the only one, so I think you can write it. So let's read this problem. Before we read the problem, just raise of hands, how many of you guys have been annotating in your AB class? Or sometimes teachers call it marking the text?
We do, but we don't like it.
Or in science? I know you probably don't like it, but you can, okay, you can put your hands down. You can also annotate or mark the text in math. And that has to do with our word problem. So guess what? This is like something you almost never do in Cornell notes, but we're going to write a question on the left for this problem together. And it has to do with annotating. So the question is going to be, how do you annotate? I told you we would use blue. How do you annotate a word problem? So even though we don't like read long texts in math, we still have word problems, right? And sometimes those word problems can get pretty long. So we're going to, whenever we see a word problem, we're going to annotate it the same way. And that way when we take a test that has like a paragraph word problem, we know what to do. So I'm going to eventually have a poster and I'll put it up here with the annotating markings. But right now we're just going to put it on the left-hand side. You are going to circle any new terms or key terms. Key terms. And sometimes in a word problem, like a short one like this, there might not be key terms. But if we ever come to one, you'll circle it. You are going to do a double underline for any relevant math information. So math info. And then if there's anything that where the actual question is, we're going to underline it and put a question mark. So we're going to underline with a question mark the actual question. Because sometimes it's not as obvious as in this problem that I gave you. Okay? So you guys have been in some of those word problem scenarios where you have no idea what the heck the question's even asking you. So in this one, it's a little more obvious, but sometimes it's not. So you'll put an underline and then a question mark next to the actual question. So let's annotate this problem, and then we'll work on solving it. It takes Joe 1.5 hours to create a web page. Do you think that's some important information? I'm not sure. Let's keep reading. A new program will allow him to create a web page in 1 hour and 15 minutes, but it will take him 8 hours to learn how to use the new program. How many web pages will Joe have to make for the two programs to take the same amount of time? Here's what I'm thinking. First of all, key terms. I don't really see any key terms except maybe this same amount. I might circle that same amount part. In math, what does same amount, how do we mathematically represent that? Equal. Okay. And then I need to underline some of the important math information. That 1.5 hours that it takes him to create, that's actually some important math information. So we're going to underline that with 2 underlines. Where else do you see some important math information? 1 hour and 15 minutes. And then 8 hours to learn. So plus 8 hours to learn. And then we need to underline with a question mark the actual question. Is it obvious in this one?
Yes.
Yeah. How many web pages will Joe have to make for the two programs to take the same amount of time? And I'm going to put a question mark there. So that means that's the question. Like I said, it's not always going to be that obvious. Sometimes it will be. So now we have underlined and circled all of the important information. So we're going to write an equation in order to solve this. But we have to have a variable. Whenever we define a variable, you have to tell me what the variable is and what it represents. We can use X or we can use a different letter. Does anybody want to have a specific letter they really want to use? H? H for hours? But are we looking at hours or number of pages? Read the question again. Are we looking at the number of hours he spends, or are we looking at the number of pages he creates? The number of pages he creates determines how long he spends making them, right? Okay, so we can use, I would use either W or P or X. What do you guys think? X? Okay, let's just use X. So X equals number of web pages. Okay, so you always have to define your variable. Okay, so let's write an expression to represent his old program. If it takes him 1.5 hours per page, how would we represent that? Jen? X times 1.5. Or another way of writing that is 1.5x. Is it okay that we converted it to a decimal? Yeah, it's totally okay. And then we want to know when, so then we're going to write an expression for the new one. If the new one takes an hour 15, how would we write that as a decimal, Faith? 1.25 per page, so 1.25 x. But we have to take into account the 8 hours it takes him to learn it. So what else do we have to do on the right side? Plus 8. And we want these amounts of times. So the left represents the amount of time it takes for his old program. The right represents the amount of time it takes for his new program. And what do we want to figure out when they are equal? So you put an equal in between them. Are the decimals so ugly that you want to clear them, or can we work with these? We can work with these. So we need to get all the variables to one side. So I see only one option here, and that's to subtract 1.25x, right? Okay, so let's do it. Minus 1.25x. (1.5 minus 1.25 gives me 0. Is it 0.25? Okay. X equals 8. And then we divide by 0.25. I ran out of room, so I'm going to write to the left. I got 32 pages. So at 32 web pages, the old way and the new way takes the same amount of time. If he only had to make 20 web pages, which program would you suggest he use? If he only has to make 20, the old one or the new one? The old one. If he has to make 100 web pages, which do you think he should use? The new one, right? If he has to make 32, he can choose whichever one he wants. Does that make sense? Okay. So sometimes we ask you in math to justify your steps. Justify means explain why you can do that step. What property are you using, basically, is what it's asking. So it's the why behind what you are doing. So example 3, we're going to do the math work on the left, and we're going to justify each step on the right. So example 3, we have 2 times 5x minus 1 equals 3 times the quantity of x plus 11. So in this example, ladies and gentlemen, what would you do first? I would distribute. So on the left, we're going to distribute 2. So that gives me... is everybody okay if I just multiply and write out the multiplication part? Okay, so that gives me 10x minus 2 equals 3x plus 33. And on the right, we're going to justify that step. So what property did we use? Distributive. So you're going to write distributive property. The reason why I'm making you do this on your homework, it's not part of the instructions, but on the quiz you will take tomorrow, there is a problem that asks you to justify every single step. So you have an example now. Okay, what would you do next? We don't combine like terms because we want to isolate the variable by using inverse operations. Specifically, which inverse are we going to use? Subtract 3x. So we're going to subtract 3x to both sides. And even, I'm going to just do it by showing the work. If I subtract 3x, what am I going to have on the left side? 10 minus 3x? 7x minus 2 equals 33. And that is called subtraction property, or you can say additive inverse, or let's do subtraction property. Okay. I know that we didn't go over the names of all of these. When you subtract something to both sides, it's called the subtraction property of equality. If on your quiz you say subtract 3x from both sides, that's okay too. Okay? And then what would we do next? So, add 2 to both sides. So that's going to give me 7x equals 35. So if subtracting is the subtraction property of equality, what do you think adding is? Adding property or addition property. Jonah, question.
Wouldn't it be 7x equals 31 because it's minus 2, so you'd have to replace it with plus 2, and 33 plus 2 equals...
33 plus 2 is 35.
No, I thought that's negative.
But in order to get it to the other side, we add 2 to both sides.
Oh, never mind.
Okay. So guys, make sure you do show your work. So addition property of equality. And then we divide both sides by 7. And we get x equals 5. And if I divide both sides by the same number, what property do you think that's called? Division property of equality. I knew you all would pick this up. And then that's your answer. So on your quiz, it will have the problem at the top, and then it will just have lines on the left side for you to do your work, and then lines on the right side for you to state the property that you used or the reasoning, so to justify. Okay? So that's why we did it this way, so you have practice. As always in math, guys, we always have special cases. So these last 2 examples are examples of the special cases. Example 4 we're going to do first, and then we're going to go right into example 5. So if you just leave yourself a little bit of space, that should be enough. So example 4, we have 10x plus 12 equals 2 times the quantity of 5x plus 6. So the parentheses mean quantity. What would you do first, Kiki? I would distribute also. So on the right-hand side, we're going to distribute. And that's going to give me 10x plus 12 equals 10x plus 12. What do you notice? What happened? They're exactly the same. If I were to keep solving, so if I were to subtract 10x, what happens to all my 10x's? They cross out, so I would have 2 equals 2. Is that a true statement? Yeah. So we call this infinitely many solutions, because no matter what I plug in for x, you will always end up with 2 equals 2 or 10 equals 10. You'll always end up with a true statement. So that's called infinitely many solutions. What? It depends on what you plug in.
It's 12.
Times 2. Oh, 12. Whoa. Whoa. Thank you. 12 equals 12. It doesn't matter. I mean, it'll come out to the same. So that we would say there's infinitely many solutions. This is also a vocabulary word called an identity. So on the left-hand side, you could write your question, what is the identity? Or what is an identity? And then tomorrow we'll add it to our vocab page. An identity is when you have infinitely many solutions, or a true statement. Everything cancels out, but you're left with a true statement. Okay? So let's do example 5 really quick. I'm sure you might be able to guess what's going to happen here. What would you do in this one, first of all? Combine like terms. So I have negative 3m and 12m on the right. So what does that give me? 9m. So on the left I have 9m minus 4 equals 9m plus 5. We need to get all the variables on one side. So I'm going to subtract 9m. That should make sense, right? What happens to 9m on both sides? So I'm left with -4 equals 5. Is that a true statement? No. So we would say, if it's not a true statement, we would say no solution. So if everything, and the symbol for no solution is a 0 with a slash through it. So you could give me it in words, no solution, or the 0 with the slash through it. That means that no matter what I plug in for m, it's never going to be a true statement. So there is no way that these two lines, when we graph them in the next unit, will ever intersect. There's no answer here. So that's a no solution. So you guys, I already did 2 of the questions for you. So tomorrow after we check the homework, I'll give you time to do the summary. But I do want to alter the homework. So get out your homework log for me. Or if you want to just write this at the top of your paper or in your planner, that's fine. But I'm going to alter it. Because all of those problems that I have are all fractions and decimals, and that's just mean. So we are going to do page 25. So your homework is going to be page 25, numbers 9 through 16. You're going to do all of those, and then let me pick a couple word problems. 27. Let's do 27 through 29. Okay, so that's going to end up being like 10 problems total. Okay, so I altered it because otherwise you're doing fractions and decimals all night long, and that doesn't help you for if you really understand the concept.